Hi, welcome to lesson 4. In this lesson I'll teach you about Linux essentials. This includes Linux skills and commands that are commonly used in bash shell scripts, including echo and printf, shell options, patterns and grep, as well as regular expressions. And next you'll learn about common text processing utilities, which includes cut, till, set and awk. I'll also explain why even if these commands are cool, you should be careful using external commands in shell scripts. And at the end of this lesson, you'll find a lab that allows you to brush up your Linux skills. If at the end of this lesson you feel you need more, don't hesitate to take my Linux Fundamentals complete video course. So, no worries, this is not a course about Linux fundamentals, but Bash is the native shell for the Linux environment, and that means that it's almost unavoidable to know at least a little bit about Linux. And that's exactly what we are going to do now. I'm going to introduce some fundamental commands that are commonly used in bash environments. To start with, echo. So what is echo? Well, echo is a so-called bash internal that is used to print text on screen. Bash internal means that it's not even a Linux command, it's a bash command. It's a part of the bash shell and you will always have it. Different options are supported to manage special characters. Echo works with command line options. To use the formatting options that Echo is offering, use echo -e and then you put the string between double quotes. And these formatting options include /b for a backspace, or /n for a new line, or /t for a tab. As an alternative, you can use printf. Printf has its origin from the C shell and it's offering some features that Echo is not offering at all. But if you only use Echo, you will be a fine scripter as well. So let's have a look at some of the things that you can do with the echo command. So let me start by typing echo hello. And what is echo hello doing? Well, echo hello is just printing the text hello. That is not too interesting. So if I want to do something that's more interesting, I'm going to use echo -e. For example, echo -e followed by b/bc. Now what is that? B, or better, /b as a formatting option with the echo command is a backspace. What is happening when you type a backspace? That's right, you remove the character to the left. So here in the string we have b followed by /b followed by c. And /b is removing the b. That's exactly what's happening here. Now let's change this command and let me show you n. N, which is new line. New line, well, that means that you are going to go to the next line. So that is what we see here. b/nc will print both of them on a separate line. This is not the most readable way of treating new lines, but you can do it. The third and last thing that I want to show you about echo is t. T is for tab. So let's use echo bt, and you know what? Let's make this real fancy and do it this way. Let me think about it, then we will run, and then I'm going to tell you what exactly is happening. Is this readable? Of course it's not readable. Who's talking about readability? It's all about the things that you can do. And do you see what's happening? Oh no, I made a typo. Here we are formatting columns with the echo command. So we have b/t and followed by c/t, which is b and a c with a tab behind it. Then we have d/n. So we continue on the next line. And next we have e/t and f/t, which is, again is two letters with a tab behind it and a g to the end. We don't need a /n to the end because that comes automatically. So here are some examples of what you can do with echo. Don't focus on it too much, it's just a little help, and you will be fine if you just use echo without any command line arguments. But it's good to know that you can do formatting as well. Alright, let's talk about printf. So what is printf? Printf, like echo, is used to print text on the screen. The main difference between echo and printf is that printf is offering some more formatting options, which all have their origins in the C programming environment. So printf does not print a new line character by default. In order to do so, you need to tell it to do so. So that would be printf, then between quotes you have the formatting string. %s /n between double quotes, and then hello world is the new line that you want to print. So the %s is the format string, and /n is the new line formatting character. /t is also common, and it's used to print tab stops. The format string is applied to all arguments that are used with printf, and that makes it a little bit more complicated and also a little bit more work. That is why many people are using echo and never are using printf. But the printf users would say that printf is so much more powerful. Now there's a couple of commands that you should compare, and this is all about the use of quotes. So let's have a look at these three commands. You can see them on the slide, but I'm going to run them from my console for you. To start with, I'm going to use printf formatting string between the double quotes. And what is that doing? Hey, that is interesting. This is printing hello and world on a new line. Good. Now I'm putting hello world between double quotes as well. And there we can see that the meaning is different. And what is going to happen if I use hello as well as world between double quotes? Well, that is using them as separate entities again. Now what is happening here? What is happening is that printf is recognizing a string, and after every string it will put a new line. Now there's the internal field separator, which is a space, and in the first line it interprets a space, and because of the space the formatting string is applied to hello as well as world. In the last example we have made that more explicit by putting hello as well as world between double quotes. By identifying multiple strings you can also do something like this: hello my world, where my world is between double quotes, and you can see that the space is not interpreted. And that is because of the use of the double quotes. Double quotes are mainly for not interpreting space. So we need to talk about printf formatting strings. %s is used to identify the arguments as string. Then there's %d as well, which is used to identify the arguments as integers or numbers. And %f is used to identify the arguments as floats. While using formatting strings, further specifiers can be used as well. Which we see when we use printf %f /n on 255. And here we have %.1f /n on 255, and here we have another example. Now I can imagine that you're confused with printf, so let me just run these three lines in a demo. So I will start using printf %f /n to 55. Which is telling it it's a float, so it's printing 255.00000. Hey, that is interesting. What's happening if you make that %s? Then it's interpreting as a string. And do we see a difference if we use %d? We don't, because it doesn't have any decimals. Now let's get back to the %f. You can apply further formatting to %f, and that is what reveals the real power of printf. So let's do a %.1f, which is printing one decimal instead of multiple. Now you can also do pretty cool things with printf, as in for I in, which is not a part of printf, which is what we call command substitution. And it's running on the result of the command seq. It's printing a sequence, and the sequence is 1 up to 10. So for each element in the sequence 1 up to 10, do printf. It's going to run printf, followed by %04d/t. And you will see what the 04 is doing. And then we need to print the $i. $i is a variable, but that represents the string that we are doing the formatting on. And I know this might be a little bit too much for now, but the example is cool, where you can see that the sequence is printing every single element, but 04d will print it as a 4-digit number. Right, I have some more demo for you. And in this demo, I want to do the following. So let me start using printf on a string, followed by 255, 0xFF, and 0377, which is giving me this. It's string, so it's just printing these different values with a new line character behind it. Let's make it D. D is a digit, And what do we see in a D? We see that we are getting 255. Now this is one of the parts where printf is interesting, but also one of the parts that's coming pretty close to the C programming language. Now what is the case? The case is that 255 and 0xFF and 0377 are three ways of specifying a number, the number 255. And by using the %d, you tell printf to interpret all of these as a digit. 0xFF, for instance, is a hexadecimal number. 0377 is an octal number. And all of these are ways to address the computer, and printf is perfectly taking care of that. Now what's happening if we make that %f? Then it's a float, and in the float we can see a slightly different interpretation where the 0377 is suddenly interpreted as a digit. Is that confusing? Yes, it is. And if I may give my 2 cents about it, focus on echo. Printf is cool, and make sure that you understand what printf is doing if you encounter it in the script, because you will encounter it. But try to avoid it, because in all of its richness it may contain features that are not that useful anyway. In this video I want to introduce bash options. So what are bash options? Well, the thing is that the bash shell script can be configured with additional options. And these additional options are telling bash how to do its work. You can use set to work with these options. For instance, set -x, and then we do an ls, and set +x will change the behavior of running the ls command. I'll show you in just a little bit. You can use set in a terminal to make it the standard behavior from that terminal. You can even include it in one of the bash startup files to make it the standard behavior for your bash shells. Or you can set the option directly after the shebang in the script to use it in that script only. As in bin bash -x, which is really telling the script to run a subshell and apply the -x option in that subshell. Additional options can also be configured from a script using shopt. Shopt +s xglob, for instance, enables extended globbing patterns. And you can use these options to allow you to add features to the shell and your script. And if you want an overview of all of the options, use shopt and it will print them. Let's go have a look at what exactly these options are doing. Okay, let me type ls. It's not about the ls command here, it's about set -x. Let me do set -x and tell ls again. Do you see the difference? The difference is that set -x is printing the exact command that's executed. And that makes that if you use set, you will have more information about your commands. And that's awesome for debugging. So set -x is one option that you might be interested in. Now let's have a look at shopt. So if you just type shopt, then we can see all the different options that are available and their current status. I really advise that you have a look at the bash man page if you want to know what exactly it is. So man, bash, and history edit. What is history edit? Well, if you don't know, the bash man page knows, and there we can see the first occurrence, use n for the next, and there we see the list of options with an explanation. So history edit, if set and readline is being used, user is given the opportunity to re-edit a failed history substitution. That's interesting, not very interesting. What I would like to show you is check jobs. So what is check jobs? Let's look it up in the man page. And we need it in the list. There we see is if set, bash list the status of any stopped and running jobs before exiting an interactive shell. Now, what is that? Well, we are right now in an interactive shell, and I'm going to use shopt -s check jobs, which is telling the shell to monitor these jobs. It doesn't show me anything. I'm going to run sleep 3600 as a background job, and then I'm going to type exit. Exit is what normally closes a shell, and it's complaining, oh, there are running jobs, and that is giving me an opportunity to kill the running job if I want to. Now, bash options are something that are a feature of the bash shell. You can use them in shell scripts as well. We'll talk about them again in one of the last lessons in this course, where I will teach you how to troubleshoot and debug errors in shell scripts. For now, let me use an FG to run my job in the foreground and Ctrl-C to terminate. And that's enough about options for now. In this video, I will tell you about shell patterns. So, what are shell patterns? Well, these are patterns that allow you to refer to text in a flexible way. And there's two sets of them. First, there are regular expressions, which are patterns that are used by specific tools. This lesson is not about regular expressions. This lesson is about globbing. Globbing is for file patterns in Bash. And basic globbing applies to standard features. So you may have seen star, which matches 0 or more characters. You may have used it in commands like ls star, for instance. Or question mark, which matches any single character. Or the square brackets, which matches any of the characters listed. Of course, you need to replace the dots with the characters you want to match, like A, B, C. A nice feature that is not commonly known about Bash is extended globbing. Extended globbing provides additional options to these patterns. If you want to use extended globbing, you need to enable it by using shopt plus s xglob. And then you can use question mark patterns to match 0 or 1 occurrence of a pattern, or star patterns to match 0 or more occurrences of the pattern. Notice the difference between 0 or 1 and 0 or more. Or plus patterns to match 1 or more occurrences of a pattern. Or add patterns to match any occurrence of a pattern. Or exclamation mark patterns to match anything that is not including pattern. Now, in case you think, hey, that looks a little bit familiar, you are right. This is something very similar to what you are going to do in regular expressions. Let's go have a look. Here you can see a list of the options I'm going to demonstrate, and let me just demonstrate them and tell you what they are doing. So to start with, I need to enable extended globbing. So shopt plus s xglob. Oops, that looks like an error message, but it's really just a message to tell us that extended globbing is already enabled. Now let me create a couple of files in a subdirectory to make it easier to distinguish them. And that will be touch.txt and e.txt and ee.txt and ee.txt. Just some random examples. You can see that they are here. Using ls-a because file names that start with a dot, well, they are hidden files, you remember. If I use ls star txt, then what do we see? We see the star, and the star is interpreted as any character. And if you use ls-a, do we see any difference? We don't see a difference because the star needs a character, and star.txt, well, as you can see, it doesn't give a match on a 0 character. Now, what if we use ls question mark e.txt, then we get a match on 0 or 1. How about ls star e? Then we get a match on 0 or more. And how about ls plus? Then we get a match on 1 or more. And finally, if we use ls add, then we just get the e.txt, because the add matches any occurrence of pattern. Now here the pattern is pretty simple, it's just an E, so it's not doing anything spectacular. Alright, and these are some examples of extended globbing that you can use if you want to make globbing more powerful. This is nice to know. It's also one of the oddities that you will see not very frequently, but it is used in some shell scripts. In this video we are going to explore grep. Grep is a great help in many shell scripts because it allows you to filter text. You can use it to find files that contain specific text. You can also use it to filter command output on the occurrence of specific text. As such, grep is very often used in pipes to make sure that specific text is shaped exactly the way you need it to be when going into the shell script. When you are using grep, it is recommended to put the text pattern that you are searching for between single quotes to avoid interpretation by the shell. And that is because the shell is doing command line parsing. Command line parsing is the part where the shell analyzes what you have just typed. and it sees if there are any special characters like dollars or star or wildcards or stuff like that that need to be interpreted. grep can also use special characters, the so-called regular expressions, which we will talk about in the next video. And you don't want these regular expressions to be interpreted by the shell, and that is why the grep pattern should be between single quotes. Let's have a look at a few examples. First, there's grep root star, which is the shell globbing pattern star, or all files in a current directory, is searched for the occurrence of the text root. Otherwise, there's psaux pipe grep ssh, in which the output of the command psaux is searched for the occurrence of the text ssh. Now, the thing about these two commands and the single quotes is that these two commands would work perfectly without the single quotes as well. That is because in the string that grep is using to search for, there are no special characters. But as soon as you start using special characters, using these single quotes is really important. Now, grep uses regular expressions, and regular expressions are advanced text patterns that help you find text in a flexible way. We will talk about regular expressions in the next video. Oh, and by the way, did you know? grep stands for Generic Regular Expression Parser. So grep is all about regular expressions. It even exists in the name of the utility. Let me show you a few examples of grep without regular expressions before we are moving forward to the next video. So to start with, let me use psaux. There we can see the output of ps, all the processes currently running. And psaux can be used with grep. For example, if you are looking for information about the cron process, use psaux pipe cron. Hey, what did I just tell you? I told you it's a good idea to put the pattern between single quotes. Now, the problem with bash is that quotes is something that you should use, you don't have to. And bash is pretty forgiving if you don't. And for that reason, you will see that they are often omitted. Now, if you would really use this in a script, then you need the result of the grep command to be clear and not to contain any false positives. Here I see what I call a false positive. It's the grep command itself. If you want to exclude that, then I would say use grep -v grep to the end of the grep command. Now you only see the result of the command that really matters. And you can use it to filter out the PID or whatever. Also, grep can be used to search in files. For example, grep root star will search in star for the occurrence of the text root. What did I tell you? Single quotes, please. Okay, let's do it again. Now there's one more thing that we need to talk about, and that is the output here. Do you see that? There's a lot of error messages. If you don't want to see the error messages, consider using 2 greater than def null. The 2 greater than def null is redirecting errors to the null device. That's the discard device, very useful. You can see if you are grepping for a specific occurrence of a text pattern in files, the result will show you file names including the matching line. If you don't want to see the matching lines, then you might be interested in using grep -l. Grep -l is just showing you a list because sometimes that is what you want, so that based on that list you can decide how you want to move on. Another thing that I like a lot in grep is the following. Let me do a grep that is giving a little bit fewer results, like grep l on student. If you work with grep, sometimes it's not the line containing the text you are searching for, but it's the next line. If that's the case, then you can use A1. What is A1? A1 is printing the matching line including the next line that was found. So you can use an A1 and you can use a B1 for the before, so that you can see the line before, the matching line, and the line after. Especially if you are working with configuration files, where you are looking for a specific header, and it's not a header that you're interested in, but the 5 lines after, well, then you would use grep with B5 in an efficient way. This is really a command that you are going to appreciate. In particular, when you are working with ini files and YAML files that are very much oriented on headers. Okay, one more, and that is the grep -r. What is that doing? That's giving a recursive grep. And as you can see right here, the result is not spectacular, but in the security directory we have at least one file. Recursive is what you want to use if you want to include subdirectories in your search as well. In this video we will explore regular expressions. So we have talked about globbing before. Globbing is about shell patterns. Regular expressions are text patterns that are used by specific utilities. The most common of these utilities is grep, but also other utilities like awk and sed, or programming languages like Python and Perl. There are many regular expressions around. If you are going to work with regular expressions, you should always put your regular expression between single quotes. Because in regular expressions you are going to use special characters that also have a meaning for the shell. And as we just discussed when we were talking about grep, when the shell is parsing the command line, you need to make sure that the characters used in the regular expression are not going to be interpreted by the shell, but by the regular expression. And again, don't confuse regular expressions with globbing. It can be very confusing because they are very similar, but really it's something else. Regular expressions and globbing use the same kind of special characters, but the meaning that is attributed to them is completely different. As for instance, in the regular expression grep a star, where the part between single quote is the regular expression, and in this regular expression the star has a completely different meaning as a star in the shell globbing pattern. So regular expressions are for use with specific tools only. You cannot use them with all of the tools. For instance, if you are going to search for files using the find utility, find doesn't honor regular expressions. Find is going to use globbing patterns instead. But some common utilities include grep, vim, awk and sed, and there will be more. Now if you really want all the gory details about regular expressions, read the man page. And I can tell you there is a lot, really a lot to learn about regular expressions. But probably the best thing to do is to focus on the essence of regular expressions and to try to discover the use cases where regular expressions really are useful. Apart from useful, regular expressions unfortunately also are confusing. Now why is that? That is because there is different sets of regular expressions. There are the basic regular expressions. These are regular expressions that work with most of the tools. There are also extended regular expressions. That's an extension on the regular expression set, and they don't always work. If you are using an extended regular expression, you need to be aware of that, and you use grep minus uppercase E, or alternatively egrep, in order to tell grep that it's an extended regular expression that you are working with. And some scripting languages like Perl come with their own regular expressions. Now just imagine this. You are trying to use a regular expression. You're not sure how to use it. You start Googling it. What is going to happen? You find a regular expression that seems pretty useful, but what you don't notice is that it's a Perl regular expression. And I can tell you Perl regular expressions are not guaranteed to be working with grep and other common Unix and Linux utilities. So always make sure that you understand your regular expression, or better focus on the regular expressions that really matter. Right, regular expressions themselves are built around atoms. An atom is the core part. It specifies what text is to be matched. Atoms can be single characters. It can be a range of characters, or a dot if you don't know the character. In that case, the dot represents any character. Atoms can also be a class, which is what you see in utilities like tr, such as alpha or upper or alnum for alphanumeric. The second element in the regular expression is the repetition operator. It's an optional element, by the way. You don't always have them. The repetition operator specifies how many times a character should occur. That can be 0 or any time. It can be any time. It can be 0 or 1 time. It can be 1 time only. There are many options here. The third element is indicating where to find the next character. It's telling you something about the position. And notice that all of these three elements may occur in a regular expression. They don't always do occur in the regular expression. It's just the three basic building blocks of the regular expression, and it may make sense to keep that in mind. Right, let's have a look at some regular expressions. You know what? Let me pop up the entire slide. The slide contains what I'm going to show you, and let me just show you from the command line. In order to do this demo, I'm going to quickly create a file. This time I'm using Vim, my favorite editor, and I call it some text. In Vim, you need to switch between command mode and input mode. So to get into input mode, I'm pressing I, in which case I can start typing my text. So Leah and Liana and Anna and Leah Anna and Annabelle and banana and banana in correct spelling. And let's also do BT and bot and boot and boat and boot with many O's. I think that is giving us enough examples to do what is on the slide. So first thing that I want to do is grab between single quotes, and then I'm using the anchor, the caret, and I'm using an L on some text. What is this? This is looking for all lines that start with letter L. Now let me extend it a little bit to Leah. What is that giving? Nothing unexpected, lines starting with Leah. And as Liana and Leah Anna also match, we see these lines as well. If you don't want that, then you can use the dollar to the end of the Leah string. Dollar is line should end with. Now sometimes you don't want to see a line that ends with, but you want to see a word that ends with. And then you can use /b. /b in this case is showing words starting with Leah and ending with Leah. So in this case we see Leah as well as Leah Anna. Good, let's have a look at some more, and let me use grab b dot star t on some text. So what do we see? We see that we are using a dot and a star. So the dot is the any character. It matches any character that you might like. The star stands for 0 or more times. So we see everything that starts with a B and a T basically, as that is what we have done in this specific file. Next, let's use a plus. And I am going to use grab B O plus T on some text, and that is giving me nothing. Now that is weird, because a plus should give us one or more times. No, that's not weird. I wanted to show you how this can be confusing, because this is not an ordinary regular expression. It is an extended regular expression. And extended regular expressions should really be addressed as extended regular expressions using minus uppercase E. Likewise for dollar. So dollar is also an extended regular expression, which matches 0 or 1 time. You can also be specific about the number of times. So if I'm going to use, and that is no longer an extended regular expression, if I'm going to use BOT but /3 with the curly braces, then what do we get? Then we get the text where we have 3 O's. It happens to be that I don't have any string with 3 O's. So let me do it with 2 O's, and there we can see. And that is basically all that I would focus on if I were you about regular expressions. Now I know that big books have been written about regular expressions. And if you find the book, it's a classic. Read it, but don't take it as extremely important to learn all that you can about regular expressions. My advice is regular expressions are important. Regular expressions are used in shell scripts, and you will write more powerful shell scripts if you really master your regular expressions. But with the regular expressions that I have just demonstrated and you have seen on the slide, you will be able to get around and to get most things done. In this video we are going to explain some common utilities to deal with text, which are cut and sort. So what are these about? Cut allows you to filter out fields based on a field separator. The example that you see on the slide, cut -d colon minus F1 on etc pass WD. Now what is etc pass WD? etc pass WD is a file that contains lines. In these lines we have fields, and between these fields a colon is used as the field separator. So if we want to identify the first field, you can use cut minus D colon minus F1. The minus D colon is to tell cut that it should use the colon as a field separator, because that's not something that's obvious. So many of these utilities, that goes for awk as well, really need you to tell you what is the field separator. Now cut is nice, there's also awk. Awk can be used for more advanced options. That makes it a little bit more complicated as well. Next I want to talk about sort. Sort allows you to sort items. Without any options, sort will happen just based on the order of characters in the ASCII table. But if you want to sort numbers, for instance, you might want to use sort minus n for a numeric sort, or sort minus d for a sort in dictionary order. Many other useful options are available. Consult the man page if you want to know more about how to use sort. Now utilities like cut are using an IFS. IFS is the internal field separator. And the internal field separator by default for most utilities is a space. And many commands do have options to define the IFS that should be used. So if you have fields that are not distinguished by spaces, make sure to specify your IFS, because otherwise your utility is not going to work out the right way. Let me demonstrate these two utilities. So let's start with the example that we have just seen. If I'm using cat on etc pass WD, then we can see what etc pass WD is all about. It's the user database on a Linux system. Now I would like to work on the third field, so I want to use cut to filter out the third field. How do we do that? Well, a cut, and first let me do it wrong. Cut minus F3 on etc pass WD is giving us what? Is giving us the entire contents of the file. Cut doesn't understand how to do this because I did not specify the IFS. So cut minus D colon minus F3 is showing us the contents of the third column. Now, as you can see, the contents is shown in the order of occurrence in the file. Maybe that's not what you want, and that is why you might be interested in sort. And this is the default sort. The default sort is an ASCII sort. And in the ASCII sort, this is not aware that there are numbers involved. So it first prints all numbers starting with a 1, then it continues all numbers starting with a 2, and so on. And if that is not what you want, consider using sort minus n. That's the numeric sort, and numeric sort in many cases is more useful. I think this is enough about cut and sort. Let's move on to the next video to talk about tail and head. In this video we are going to explore tail and head. So tail and head are very simple tools. They allow you to print lines on the top or on the bottom of a file. And you can use them as simple filtering tools. And you are going to appreciate the simplicity of these utilities. Now, simplicity is one of the things that's always good in a bash shell script, because simple utilities are faster utilities. And if you use a simple utility on a shell script that is going to do a manipulation, let's say 1,000,000 times, then you really will gain significantly in the time it takes to execute the script. So here is just one example. Tail minus 3 etc pass WD prints the last 3 lines from etc pass WD. Notice that older implementations of tail as well as head needed minus n3 for the number. The modern alternatives just allow you to pass the minus 3. And likewise, head minus 3 etc pass WD will print the first 3 lines. If next you send the result to a pipe and beyond the pipe you use tail minus 1, guess what? Guess what you get? You get the third line. Let me show you. So let's start with tail etc pass WD. As you notice, I did not specify any number. If you don't specify a number, you get the last 10 by default. And we can modify that by using minus 5, for instance, which is completely the same as tail minus n5. 5. You might be on an operating system with an older version of these utilities. You might need the -n. So let me show you both of them. Now the next thing I want to show you is head -1, which is doing what? Well, out of the last 5 lines, head -1 is printing the first line. And that might be convenient because in some cases new information is just added to the end of a file. So you use till, or the beginning of a file contains a header, so you want to use head. If for instance PSAUX, you want to know what all these numbers are all about, well, the very first line contains header information. So use -head3 just so that you can see the header information in the first couple of lines to see how it relates. Again, till and head are pretty simple utilities, but they are nice in their simplicity, and that makes them really useful. In this video, we are going to talk about sed, one of the most impressive utilities that was ever created. Now, what is so impressive about sed? Well, sed is a stream editor, and it allows you to edit files even if no full screen is available. It's hard to imagine, but in the time that sed was invented, the late 1970s, computers did not have full screens attached. And computers very often were line-oriented. So you needed something smart to edit files in a line-oriented way. And that is sed, the stream editor. Really, it's a programmable editor. When you are going to get more in-depth information about sed, you should keep this 1970s background in mind, because sed was developed to do a job that's not really needed anymore. And for that reason, in sed, you will find that sed includes its own programming language and very many options. But my advice is not to focus on all these advanced options, just make sure that you learn about the basics of sed. Now, what are these basics? Well, the basics are to print a line, to substitute, to delete, and to delete in a batch way if you want to. This is what I'm going to show you in the demo. If you want to know more, pinfo sed has very nice examples. So I would advise you consult that. Or read the big book that was published by O'Reilly, Sed and Awk, which will give you a nice insight into everything that you can do with the sed utility. But if you are going to read it, do notice that many people are not using this advanced functionality of sed anymore. Let's go check out sed. Right, let me start with sed -n 5p etc pass wd. So what is this doing? This is passing the command where we print the 5th line. I like the sed way of changing information in a file. So let's have a look at the some text file that we created before. And I am going to use sed in order to change it. In order to do so, I'm using -i, because -i is writing interactively. Sed was created to write the result to the standard out, so that you can use it in a pipe and redirect it to a new file if you want to. If you want to write directly to your file, then you can use sed -i followed by whatever you want to do. So I would use s/bot/bet, for instance, on my file some text. Which is doing what? Well, catch some text, we can see that the bot has been replaced with bet. If you look at the slide, then on the slide you can see that there is a G as well. What is the G? The G is for global substitute. So let me use sed -i s/an/an/ on the file. And then let's check what has happened. And you can see that only the first occurrence of the string that we have replaced has been replaced. So we have an and that's it. Now, if you want to replace an anywhere, then you would need to add a G. The G is global. And global in this context means if you have multiple occurrences of the same pattern in the same line, change all of these occurrences. And here you can see that this time the result has really changed everything. Also convenient is the option to use sed to delete a line. You may have seen it in some cases. You get an error on a specific line. If you get an error on a specific configuration file line, then you may think, oh, I need to edit it and remove this line. And that's exactly what sed can do in an automated way. So set minus I, because again, we want it to be interactive, minus E to pass an edit command, and the edit command is 2D on the file that you want to edit. And the result, well, it's hard to see the result, but Liana, who existed on the second line of this file, has now been removed. Set can also be used in batch, and that is something that you might like very much. Let me create echo hello to a.txt as well as b.txt. I just want you to see the example of multiple configuration files. Now I'm going to use a quick shell script construction for I in *txt. What does that mean? Well, this is doing an iteration and it's checking for *txt. And as you know, *txt is all files that end in txt. For I in, that means that for every single file that was found, it will put it in a variable with the name I. And next we are going to use this variable by using do set minus I, s for substitute, /hello /by, and make it a global substitute if that is necessary on $I, and then you close the small shell scripting iteration using done. This is a construction, by the way, that you will learn more about later in this course, because in the end it's a part of shell scripting. So now it has changed the contents of all of these files. So if I do a cat on a.txt, we can see it has a by, and likewise for c.txt. Right, again, if you want to know more about set, pinfo has nice examples. But there is one thing that you should be aware of, and that is that set is a very powerful external command. External command means that it needs to be fetched from disk. And if you are fetching commands from disks, that will make your shell script slow. So that is something that you better avoid. I'll explain in more detail later what to do with these external commands and how to deal with it. In this video we will explore awk. Awk is another one of these utilities that come from the time of sed, where awk is a filtering utility. It has a little bit of grep, it has a little bit of cut, and it has a little bit of everything. But most of it, awk was also developed in the 1970s, so it contains very many features, and many of these features are not that relevant anymore. So when you are going to explore awk, you should really wonder if it's a relevant feature or not. And if not, just don't use it. I have tried to summarize the most important examples of using awk on this slide. So let me run a couple of examples with awk. First, the classical example, awk -f colon. That's the IFS again, the internal field separator. And we need to tell awk what field it should be looking at. Awk is a little bit more flexible regarding IFS. It will be able to make the difference between tab and space as the IFS, but if you want to be sure, you better specify it. Then we get single quote, and between curly braces you get the awk command. So here the command is print $4. And what is $4? $4 is a fourth element of etc pass WD. There we go, and we can see the numbers again. Now that is something that you can do with cut as well. And if you are going to do it with cut, then probably your script is faster also. One thing that you cannot do with cut is the following. Awk -f colon, which is still mandatory. And then we start the operation, and I am looking for student. And for student, which is the matching pattern, for the matching pattern I want to print the $4. And we do that in etc pass WD. And that is kind of awesome, because this is something that otherwise would be quite difficult. Well, quite difficult. You can do it from the command line by using grep student on etc pass WD, by piping the result of that command to a cut command, for instance. But that would be two commands, and here it is just one useful awk command. One more example, you can even go a little bit further in the specific operation. So what we have seen here is a search operation. The other example is awk -f colon, where we are looking for $3 to be smaller than 999. And only in that case we are going to print $1 and still on etc pass WD. And in case you are wondering why is this useful, well, this is useful because on Linux you have system IDs and you have ordinary users, and system IDs normally are users with an ID smaller than 1000. Okay, I did smaller than 999. Let's do it on 1000. That shouldn't give us any difference anyway, but hey, it's nicer. So in the previous couple of videos you have learned about essential tools that can be used in shell scripts. And many of these tools were external utilities. Now before we are continuing and starting finally to focus on the shell script itself, a few words about external tools and performance. The best practice really is to avoid external tools. And why is that? Well, that is because external tools and all the libraries they require need to be fetched from disk. And fetching them from disk is relatively slow. And also external tools are operating system specific, sometimes even distribution specific, and that makes your script less portable. If you want to know if something is an external tool or not, best way to do so is by using type. Type will tell you what it is. You can also use which, but which is a little bit more limited as it will only show you the path to the utility. And at any time, if you want to measure performance, you can use time my script to measure the amount of time that it takes to run a script with or without external tools. Let's go explore these external tools a little bit and see what you can do to avoid using them. A good way to get started is by typing help, because help will show you the utilities that are a part of the bash shell. And you can see that there are many utilities available within the bash shell. The funny fact is that some utilities are available as an internal tool as well as an external tool. The thing is that in the search precedence and the order of execution precedence, internal utilities will always win. So if you have an internal utility and an external utility, don't worry about it. The internal one will always win. And if you want to use the external one, you need to be very specific. Let me give you an example. If I use time ls, then I get the output of the time that it requires to run ls from the internal utility. If I use which ls, I know that ls is also somewhere in the search path. If I use which time, I know that time is also somewhere in the search path. So here we go, /user/bin/time. And if I use user bin time on ls, look at that, we get a different result. And that is showing you the difference between the internal and the external utility. So why would you want to use the external utility? Because it is giving a different result. And maybe that is exactly what you're interested in. Like the information about the page faults and the swaps that I'm getting from user bin time. Type is a convenient utility. If you type, that doesn't make sense. Yes, it does. Then it will tell you if something is internal or external. So you will find shell keyword and shell built-in, both of them indicating that it's a part of the shell. Now this time utility, and you can just use the internal time utility, is a very nice utility. Let me, for example, use time followed by awk. What do I want in awk? Well, awk minus f colon, and then I'm going to print $1, for instance, on etc pass WD. That is something that we've just done in a previous demo, and here we can see using time how much time that takes. Oh, that's not too bad. The real time is 1 millisecond. Now if you really want to measure performance and see if one utility is doing better than the other utility, like cut for instance, then use the other utility as well. Cut minus d colon minus f1 is giving me 1, is also giving me 0.01 seconds. So both of them are very fast. In this case, the difference can be ignored. In some cases, you won't be able to ignore the difference. And if you want to optimize a shell script for speed, then I would say first, always look for the internal utilities. And in case of doubt, create a shell script with the internal utility as well as the external utility and run it with time. There's one more thing that I want to show you, and that's the dependencies. If I use LDD on awk, oh, I need LDD on which awk. This is a simple example of command substitution, where the result of the command which awk is used as the argument to the LDD command. And here we can see the libraries that are used by the awk utility. And if we do the same for the cut utility, we see what? We see that the cut utility is using one less library. So what does that mean? That means that theoretically the overhead of using the cut utility is smaller than the overhead of using the awk utility. And that is useful if you can't avoid using an external utility. If that is the case, then you should investigate the libraries to get more information about what exactly is happening if you are running this utility. We'll get back to this, and later on I will show you how to measure performance on specific scripts. But to start with, try to avoid using external utilities if an internal utility is available. We are now at the end of lesson 4. Let's practice a little bit before continuing. So here is the end of lesson lab, which is about using Linux commands. First, use the appropriate commands to create a list of all users on your Linux system that have a UID higher than 1000, and the list needs to meet the following criteria. Full lines from etc passwd are printed. The list is alphabetically sorted by username, and any occurrence of bin bash is replaced with bin zsh. Also, changes are not written to etc passwd, but tmp my users. So don't change etc passwd itself. That might be very dangerous. Good luck. All right, have you been able to find it? Then you're good, because this lab had a couple of challenges. Challenge number 1 is, how do we find lists of users on your Linux system that have UID higher than 1000? Well, etc passwd is what we are looking for. And we are looking for the third field, because in the third field we have the user ID. Best way to filter out these users is by using awk. So awk -f colon, and next we are going to look for $3 greater than, well, let's make that greater than 999. What are we going to do on $3 greater than 999? We need to print the entire line. And one way to print the entire line is by using print $0. We did not discuss that, but print $0 is printing the entire line without printing any fields whatsoever. So what do we see? We see that this is quite successful. And oh, we also have nobody. Nobody has user ID 65534, so that matches what we are looking for, right? Good. Next, we need to make sure that the line is alphabetically sorted by username. That should be relatively easy. Just use sort. You don't need anything else, because the output lines start with the username. Otherwise, you might use sort -k to sort on a specific column. That's also something that we have not discussed, but which is definitely possible. Then we need to change any occurrence of bin bash with bin zsh. Hey, did you see that? These users have bin sh. That's something that we need to investigate next. But let's first on the substitution task. I would say use sed. Sed is a substitution utility. Now, how do we use sed? Let me first remind you of what we need to do. We need to do something like this. But then we need to replace the old new with /bin/sh and /bin/zsh. Now, what is the interesting thing here? The interesting thing is that in the sed substitution, the slashes have a special meaning. So if we are going to substitute anything that has a slash, then we need to escape these characters. And that means that we cannot just put in this, because then sed would be so confused about what you are going to do. We need to make sure that all slashes that are a part of the pattern that we are looking for are properly escaped. And that means that all slashes that are a part of the path are escaped like this. So this is what the string would be looking like. And there we go. You can see that just in the output, the result has changed. Z-I would change in the original file. Well, that's not something that's going to happen anyway in this example, because we don't have a file, we have a pipe. We change it out of the pipe. This is what the command looks like. Now, before we continue, echo $shell was giving us what? Is giving us bin bash. I am user student, and user student, oh look at that, user student does have bin bash. Only user Anna and user Linda, which are users that have been created later, get bin sh by default on Ubuntu. If you want that to be bin bash, then create the user referring to bin bash as well. Just curious, I am going to use ls-l on $which sh and also on $which bash. Again, we use a command substitution to print the complete path names of these utilities. And there, what do we see? Aha, that is interesting. We see that the original user that was created is getting bin bash. We can also see that additional users on Ubuntu are getting dash. So we have a hidden dash here. Now that we are doing this, as the bin sh is a symbolic link, let's check out this bin dash. And there you can see one of the reasons why using dash might be interesting. Dash is about 10% of the size of bash. Definitely some features will be thrown away with that. But the good thing is, regardless of what your users are using, even if they are using dash, well, just use your shebang and your shell scripts will be working. And that's all for this lab solution. Let's move on to the next lesson.